Binary search tree deletion operation. The third operation is performing deletion in a binary search tree. Deletion is nothing but deleting a node from the binary search tree. Here utmost care should be taken that the properties of binary search tree are not violated and nodes are not lost in this process. So we will take up 3 cases in this section and discuss how a node is deleted from a binary search tree. When it comes to deletion, there are 3 cases are there. The very first case is if it is a leaf node, the node which you want to delete is a leaf node, simply you can remove the node. You don't need to follow any different procedure, or there are no conditions applied on removing the leaf node. Simply if it is a leaf node which you want to delete, you can remove it. Second scenario is, the second case is node with one child. Suppose you want to remove one node but it has only one child, either it can have a left child or right child, but it has only one child. The node which you want to remove has one child. If so, remove the node and replace it with its child. So before you remove the node, you are supposed to replace that node with its child node. That is case 2. And case 3 is node with 2 children. Suppose you want to delete one node but it has both the children. If so, some replacements we are supposed to do, right? So if the node which you want to delete has both the left child as well as the right child, find the node's in order successor or in order predecessor. In order successor is nothing but the smallest value in the right subtree, or suppose if you are finding in order predecessor means the largest value in the left subtree. So either you find the node which you want to delete, that node's in order successor or in order predecessor, and replace the node's value with the successor value and then delete the successor node. So here if the node has only one children means you can just replace it with the child and you can remove the child node. But here if the node has both the children, you are supposed to find in order's successor or in order predecessor and then replace the node which you want to delete with this successor value, and then you can delete the so and so the successor value, right? Let's discuss the pseudocode. You will understand these 3 steps in a clear way. Fine, this is the given example. Example tree structure is given here. I want to delete 84, 41 and 58. How to delete 84? First let's check. There are 3 cases, right? Either you have to check whether the node has children or no children, or it has only one child. You are supposed to check. If I check the data element 84, if you check, it is a it is a leaf node. The node which you want to delete is a leaf node, which means it is not dependent on any other node. It is not acting as a parent for any node here because it is a leaf node. Directly you can go find the node and remove it. Simply you can remove it. After removing it, this node will not be considered. In the resultant tree, this node will not be considered. So directly you can find the node which you want to delete and you can just remove it. That's it. I just removed 84. First step is done. Second step is I want to delete 41. If you look at 41, if you check here, yes, 41 has one child. This is condition number 1. Case 1 is applicable here and case 2 is applicable here for deleting 41. If you check 41, it has one child. If it has one child, the scenario is different. It can have either left or right, but if it has only one child, the thing is, read step number 2 again. If the node has only one child, remove the node, but before you remove the node, replace it with its child. The node which I want to delete is 41. You replace this node 41 with its child. Its child node is 13. So I am just replacing this 41 with 13. And after replacing it, now you can remove 13. This is how you are supposed to perform deletion if the node has single child, right? Replace the node with its child node. After replacing it, remove the child node. That's it. So after removing the child node, this is how my tree would look like, right? Fine. Second step is also successfully done. It satisfies the second case. And the third case is, the third element which I want to delete is 58. It is not yet done. The element 58 I want to delete. Where is 58? 58 is here. If I check 58, yes, it has both left child as well as right child it has. If so, how to delete it? There are further nodes also are there. If so, this is second case. If the node has two children, find the nodes in order successor or in order predecessor. In order successor is nothing but the smallest value in the right subtree. In order predecessor means the largest value in the left subtree. I am going to find, you can find anything, either you can go with in order successor or in order predecessor, you can go with anything, but I am going to go with in order predecessor. In order predecessor is nothing but the largest value in the left subtree. Let us find out. Nodes in order predecessor, right? In order predecessor means the largest node in the left subtree. This is the node I want to delete. Look at the left subtree. The largest node in the left subtree, you need to find it out, and this is the largest node, 56. After finding out the largest node, you just replace it with the largest node, which is 56, and then you can delete this. Now if you check, yes, it satisfies the constraint. It is not violating the binary search tree property. Either you can go with in order predecessor or in order successor. In order successor is nothing but the smallest value in the left subtree. If you check the left subtree, if you check the left subtree, it has 80 and 69. Out of these two, the smallest value is 69. So this node can be replaced with the 69 and you can ignore the 69. So even if you ignore this also, it satisfies the constraint. It is satisfying the property, right? So either you can replace the node with its in order predecessor or in order successor, and this is how the resultant node would look like. Hope it is clear. If it is a leaf node, directly you can remove it. If it is if it is a node with a single child, you can replace the node with its child and then you can delete the child node. Otherwise, if the node has both the children, means you can go with finding in order predecessor or in order successor and replace it with in order predecessor value or in order successor value and then delete the successor value. So definitely the in order predecessor as well as in order successor would act as a leaf node only. So you are replacing it with the leaf node, the proper appropriate leaf node, and then deleting the leaf node, because deleting the leaf node is going to be the easier one, right? So you are going to delete the leaf node directly after replacing it with the node which you want to delete. Now let's discuss the pseudocode, and this is the pseudocode, and we are supposed to consider three conditions here, right? Node with no children, node with a single child, and node with the two children. Here this first two lines, the delete is the function and tree is the root node and value is the value which you want to delete. And first you have to check if the tree is equals null, which means if the tree is empty, tree is null, it means that the value is not found in the tree, right? So we are supposed to print that, print a message indicating that the value is not found and exit the function. So these two lines are, if the tree is completely null, you are supposed to print that the value is not found in the tree. Next, these four lines are for to traverse the tree to find the node which you want to delete. For example, the node which I want to delete is 69, means the node which I want to delete 69 means I am supposed to find it out, right? Where exactly the node is, I have to locate the node. So to locate the node, these like these four statements we have used here. You have to check the value which you want to delete, 69, is lesser than the tree data, means you are supposed to traverse towards the left hand side, which means it would traverse the left subtree. Call the recursive call, the function which is delete function. If it is greater, the 16 is greater than the root node, you are supposed to perform the traversal towards the right subtree, so that the element would found in the right hand side since it is coming greater, right? So these four lines are for to traverse the tree to find the node. If value is lesser than the current node's data, the value we are looking for is in the left subtree, so we recursively call the delete function on the left subtree. Otherwise, if the value is going greater than the current node's data, means the value we are looking for in the right subtree, so we recursively call the delete function on the right subtree. Fine. If it is null, it would return the tree is empty, the value is not found. Otherwise, if the tree is not null, to find the data, these four statements we are supposed to use it to traverse the data to find the node. And next is the node to be deleted is found. So the node to be deleted is found, and the node has both right children as well as the left children. If so, these are the statements. The node is to be deleted is found with the two children. The first line is else if the tree has both the left child as well as the tree has both the right child. In this scenario, if the node, we need to find the largest node in the left subtree, which means in order predecessor they are found. In order predecessor they have identified with the help of find largest node function. We are supposed to find the largest node in the left subtree to replace the current node. So in the left subtree, in the tree left, we are finding the in order predecessor, which is finding the largest node, and the largest node's address has been stored under the temporary variable temp. And then after storing it under the temp, after finding the largest node, the tree data, the node which you want to delete is replaced with the temp's data. We are supposed to replace it with the in order predecessor, right? In order predecessor has been stored under the temp variable. Temp's data must be replaced with the node's data which you want to delete, and then recursively delete the node, the temp data from the left subtree, and then delete recursively from the left subtree, the temp data must be finally deleted. Next, these statements are for if the node has one children or no children. So you find out the node which you want to delete and store it under the temporary variable. So this has the address of the node which you want to delete. Address of the node which you want to delete. Now you check. If the tree left equals to null, you found the node, you have stored it under the temporary variable. You check whether the node doesn't have left node and doesn't have right node. Both are null, means you can simply delete it. If it has no children, directly you can make it null. You can make the address, the root node, as null. Otherwise, you check if the tree left is not equal to null, which means the left is not equal to null but the right is null. If so, you are supposed to change tree equal to trees left. So the node which you want to delete must be replaced with trees left. Otherwise, if the node has right child, right? If so, the current node which you want to delete must be replaced with right. If it has only right child, that must be replaced with the right. If it has only left child, the node which you want to delete must be replaced with the left child. If it doesn't have any children, you just make it as null. Come out of end, and finally the node which you want to deleting, in the sense not only excluding it from the chain of binary search tree, also you are supposed to erase the node completely and make the memory space free, so that the upcoming data element can come and occupy the so and so memory address, right? So after disconnecting the chain, finally it would come out of the if and free temp, so that the memory space would get emptied completely and it would come out of the function, the end function, completely. So finally this is end of function. So here when it comes to deletion, we are supposed to check three cases here. If it has no children, if it has single child, or if it has two children. First, if the tree is completely null, the value is not found. And next four statements are to find out, to locate the node first. Which node you want to delete, you are supposed to locate it first when the tree is not null. After locating the so and so data element which you want to delete, you have to check whether the node has both the children. If the node has both the children, you are supposed to find largest node, and that address must be stored under the temporary variable. And then you are replacing the current node's data which you want to delete with the temporary data, which means the largest, the in order predecessor. You are just changing it here, the address you are placing it in the node which you want to delete, and then you can delete it. Otherwise, if it has only one children or no children, if it has, first what you do, you locate the node and store it under the temporary variable, because finally we want to empty the space. So I am storing the address under the temporary variable, so that I can finally empty the space. And if the tree has null, both the right node and left child is null, you can directly remove it, you can make the tree equal to null. Otherwise, if left is not null, which means it has a left child node, so the node which you want to delete is what the tree is, right? Under the tree, the node which you want to delete address would be there, right? So this must be replaced with the tree left address. If it has right node, the current node must be, if it has only right node, the right child's address must be replaced with the current node which you want to delete. And finally, you just come out of if and free the temp finally, so that the upcoming nodes can come and make use of the memory space, and finally end the function after completing the delete operation. This is what the deletion operation is, and all the three cases we done here with the given example. Thank you.